All right, we are continuing the lesson on using intercept form, sometimes called factored form, and we're going to look at example 4. So this is the second video. Find the zeros of each function. F of x equals negative 2 times x squared minus 10x minus 12. What do you notice? Well, hopefully you noticed that each one of those is divisible by negative 2. So the first thing we need to do is put this in factored form. So I'm going to factor out a negative 2. If I factor in negative 2 out of the first term, I'm left with x squared. If I factor in negative 2 out of the middle term, negative 2 out of 10x leaves 5x. And negative 2 from negative 12 is plus 6. All right, then remember, you have to try to factor your trinomial even further. So we're going to rewrite x squared plus 5x plus 6 in factored form. So x times x is x squared. What multiplies to give me 6 and adds to give me 5? Hopefully you said 2 and 3. Both of those are going to be plus. And then to find the zeros, I would set each factor equal to 0. Now if I set 0 equal to negative 2, that's not going to work. 0 does not equal negative 2. So the negative 2 just kind of doesn't matter in this case. It matters, but not when it comes to finding the zeros. So x plus 2 equals 0, and x plus 3 equals 0. Subtract 2. X equals negative 2. Again, I'm using the zero product property here. Zero product property says if you've got the factor, set it equal to 0 and solve. Or if I have a product, I can set them equal to 0 and one or the other will be the solution. So find the zeros means you are just solving. All right, so B part, h of x equals x minus 1 times x squared minus 16. All right, so over here you can see, look for structure. The function in example 4b is called a cubic function. You can extend the concept of intercept form to cubic functions. You will graph a cubic function in example 7. So we're kind of looking ahead. Why is it a cubic function? This is x squared times x to the first power. Remember, same base. Add exponents, that would be x to the third power if we put that in standard form. X to the third power is called a cubic function. All right, so we're going to look at what this would look like. So this would be x minus 1 is one factor. Remember, x squared minus 16 is x plus 4 and x minus 4. All right, set each factor equal to 0. And then solve. So you can see when you have a quadratic function, you can have 2 real zeros, and a cubic function, 3 real zeros. So the number of real zeros can equal the number of the degree. All right, example 5, using zeros to graph h of x equals x squared minus 2x minus 3. All right, so let's take and try to factor x squared minus 2x minus 3. So I'm going to have x times x. 3 is a prime number, so I know it has to be 3 and 1. The negative 2 in the middle tells me the bigger number has to be negative. So I'm going to have x plus 1 equals 0. X minus 3 equals 0. So very quickly I can find my intercepts. My intercepts are my zeros. So I'm going to have x equals negative 1 and x equals 3. So 1, 2, 3. All right, and I need to find another point in between that. So I know my vertex is probably going to be halfway, well, not probably, my vertex is going to be halfway in between those 2 points. So if I want to go ahead and do that, -1 plus 3 divided by 2, that would be 2 over 2, or 1. Visually, if you look at that, you can tell that's halfway between those 2 points. So x squared minus 2x minus 3, I just plug in the 1. So 1 squared minus 2 times 1 minus 3. So 1 minus 2 and minus 3 is minus 5, so -4. So I'm going to have 1, -4 would be my vertex. So 1, 2, 3, 4. And then I can sketch the graph using those points. So that's how you use your zeros to graph a quadratic function. Example 6, write a quadratic function in standard form that has the given characteristics. Okay, so just a reminder, standard form, y equals ax squared plus bx plus c. All right, so that's our standard form. So it's always important that you understand what the question is asking. All right, A part, let's just look at one part at a time. A part says vertex is -3, 4. All right, given the vertex, we're not going to go straight to standard form. We're going to put it in vertex form first. So A times x minus h squared plus k, that is my vertex form. All right, remember if we're given our vertex, that gets substituted in for h and k. All right, they don't give us an a, so we can assume a to be a 1. So if we want to put a 1 in here, x minus h is -3, so it's going to become a plus 3 squared. And then plus 4 is our k value. All right, so this is now in vertex form. We need to write it in standard form. So I'm going to have to multiply by binomial. All right, so a binomial squared, remember we learned how to multiply that easily. It's going to be x squared. We're going to have twice ab, so a is x, b is 3, so twice 3x would be 6x in the middle, and then 3 squared is 9. Again, if you don't remember how to do that, make sure you review that. That's a huge thing on the ACT. All right, so x squared plus 6x, 9 plus 4 is 13. Now, it's in standard form. All right, so that is part A, x squared plus 6x plus 13. All right, so we wrote that given the vertex. Now, B part says we're given 2 zeros. If you're given the zeros, you're going to use intercept form or factored form. All right, so for B part, y equals, if you remember, factored form was the one that had the p's and the q's. So x minus p and x minus q. And again, those just p's and q's are just the numbers that represents the zeros. Again, this is just your formula that kind of stands for all quadratic equations in intercept or factored form. All right, now given the zeros, I can plug those in. So now I'm going to plug those in for p and q. Again, we can assume a to be 1. It's saying let a be 1, so we're going to do that. So x minus a -5 would become a +5. And then an x minus 4. All right, once again, we have written equation using the given information, but we need to change it to standard form. So we're going to have to multiply this out. X times x is x squared minus 4x plus 5x and then minus 20. Combine like terms, x squared minus 4 plus 5 would be plus x and then minus 20. All right, 2 down. All right, C part says passes through negative 9, 0, negative 2, 0, and negative 4, 20. So because these have y's of 0, this means these are the x-intercepts. If these are the x-intercepts, those are your solutions or your zeros to the equation. So we can use intercept form. So we're going to have y equals a times x minus p and x minus q. We're going to use that formula again. All right, now the first thing we're going to do is plug in negative 9 and 2. So we're going to say y equals x, and then I forgot my parentheses, so we're going to have x minus negative 9. Minus negative 9 is going to be plus 9. And then x minus q, again, x minus a negative 2 is going to make that a plus 2. And then they give us one more point. They give us negative 420. So we actually can find a because this would be an x and a y value. So just substitute that in. So we're going to have 20 equals a times x would be negative 4. So put negative 4 in both x's and then find a. So 20 equals a times negative 4 plus 9 and negative 4 plus 2. So that's going to be negative 10a. Divide by negative 10. A equals negative 2. All right, once we have that, we can plug it in the original equation here. So negative 2, x plus 9, x plus 2, and then multiply it out to put in standard form. Let's multiply the binomials first. So I'm going to have x squared plus 2x and plus 9x is plus 11x in the middle. 9 times 2 is 18. And multiply the whole thing by negative 2. I'm going to get negative 2x squared plus 22x. 18 times negative 2 is negative 36. All right, so that one is now in standard form as well. So again, remember, it didn't just say write an equation. It said write a quadratic equation in standard form. So putting this up here kind of reminds you that you have to keep doing that no matter what information they give you. Start with what you're given, but then work to get to the other form in any way that you remember how.